Okay, well, we're about to start something that a lot of people just dread. You say word problems, people run out of class screaming, I hate word problems. Why? Why would you make me do this? I get it. They're not fun because you put the challenging part about reading and kind of diagnosing what's going on with math, and they become challenging. Fun-ish, maybe? I don't know. It kind of depends on who you are, whether you think these things are fun or not. Some people love word problems. Most people just don't like word problems because they don't understand how to go about solving them. Once we start understanding how to do them, they become a lot better. Super fun, I don't know if that's your thing. I sometimes enjoy word problems, sometimes I don't because it takes just a lot more thought. That's okay. I'm going to teach you how to think about these. So in this approach to problem solving, we'll start pretty basic, and then I'll do the next few videos kind of progressing how to deal with some different word problems. Here's some general outlines on how you would go about solving word problems. Number one, the steps on this. Now, let me say first, before we get going, there's no possible way that I can teach you how to do every single word problem out there. There's an infinite number of them. You can make word problems up for everything. So I can't teach you how to do all of them. What I can do is give you 5 steps that help you think about this. It gives you just this pattern of solving word problems. Number one, the first thing that you should be doing here is reading the problem carefully. And what I mean by that is literally just read it. Try to get an idea about what's going on, but do not try to make an equation here. That's a wrong thing to do, because when you start assigning variables and try to jump into it too fast, we're going to miss some key points, or we're going to put things out of order. That's the problem. So number one, we're going to read it carefully. Number two, if you can, this is not always the case, but if you can, draw a picture or find a formula if that's applicable. So we're dealing with like area of a triangle or something, or we're dealing with square footage. That's a formula idea. We can deal with that. Or if we have like a height problem or a distance problem, you might be wanting to draw a picture. Stuff like I have on the board behind me, we'll get to in a minute. This is not a picture idea. So it depends on the problem, but read carefully for sure. Secondly, if you can, draw a picture or find a formula. Number three, after you've done that, this is for sure all the time, make what's called a verbal model. What a verbal model does, it puts your word problem into math type words. So this kind of organization of your thoughts. This is the biggest part. Most people skip making a verbal model and they try to go right to equations, and that's where most of the mistakes happen here. So verbal model, a big deal. We're going to discuss how to do that in the next few videos, sorry. After that, after you've made your verbal model, assign one variable. Now, when we get to systems of equations, I'm going to show you how to do this with more than one variable. That's pretty cool because it makes things easier. When you're able to use more than one variable and you know about systems, this becomes easier. For right now, we have to base all of our information on one variable. Never assign more than one variable when we're talking about linear equations in one variable. Lastly, yeah, you're going to solve it. As soon as you've done this, you'll have something at this point you can solve, which is kind of cool because right now what I'm telling you is that you really have all the tools to solve any linear equation like ever. You know how to deal with fractions, decimals, distribution, combined like terms, so you know how to do that. But that part, interpret it. In word problems, we never leave something like x equals 7 because that doesn't tell anybody anything. Word problems are supposed to be applicable, or at least they came from something that was applicable to somebody somewhere, so we're going to want to interpret it. So x equals 7 becomes, it would take 7 minutes to do this job, or you could go 7 miles an hour, or it would be $7, something that's relevant to the word problem. So that's what we're going to strive to do in the next few videos. Right now, I want to show you how to deal with a few common ones. A lot of teachers are going to give this to you as like an introduction to word problems. This right here, we're going to read this carefully, but this is kind of a watered down word problem. That's okay. It's to get our feet wet on it. So let's read it carefully. A number divided by 5 equals the number decreased by 24. My goal in this video is not to solve problems here. My goal is to get us to the point where you can solve the problem. So get us basically to there. Assigning the variable, making sure that we understand the concept of linear equation, and then you go ahead and solve it. So we'll read it carefully. Read it at least 2 times. A number divided by 5. Right now we're getting some math in our head. We're seeing what operations are there. We're looking for a number that means equals. Sometimes it just shouts at you. That's cool. Equals the number decreased by 24. No problem. So we're getting these things in our head, but we're not writing anything down yet. Number 2, drawing a picture. That's not really relevant. We're not going to draw pictures of numbers here. That we're going to write numbers, but not really a picture that would make sense. And there's no formula. Number 3, step 3, well, the verbal model, that's actually what we've been given here. So this is a verbal model already. So we kind of skipped a few steps. This is given to us at step 3. So make a verbal model, we got it. Here's the idea. When we assign one variable, we're going to go through on these problems that are basically verbal models already. It's good practice to make a verbal model into an equation. That's why these are given to you by most teachers. Go through and read it really carefully. And every place where you see an operation, I want you to underline it and put the operation. Where you see the one thing that means equals, underline that and put the equals right below it. You see, when we understand how these problems work, anything that's written after the word that means equals goes on the right-hand side of your equation, and anything that's written before the word that means equals goes on the left-hand side. So let's start with that. So let's read through real carefully. A number, well, what's a number mean? So a number, we go, what number is it? I don't know. That's what gives us a variable. So when you read a number, that means a variable. When you read the number, that's referring back to the variable you've picked. It doesn't matter what variable you pick. Most people pick x's and y's because we're used to it. So we're going to read this and just say, okay, a number. Underline it. That typically means x, y, or whatever you want. Divided by 5. Well, let's underline that. Divided by, well, that's straight up like a division problem. I mean, we know that. So let's put divide. We got that. The key one here. The word that means equals is crucial for you to find. A lot of times it's words like equals, is, was, represents, represented by. A lot of those different words are these word clues that tell you what's going on in the problem. Here for us, we have just equals. Very straightforward in this problem. So a number, we got x. Divided by, we got divide. Equals, now this tells you something. All of this is going to be one expression, and this is going to be on the left-hand side of your equal sign. This stuff goes here. The stuff after the word that means equals, sometimes equals, sometimes is, sometimes was. This stuff is going to go on the right-hand side. So let's diagnose that real quick. So the number, whenever it says the number, it's got to refer back to the variable that you've already picked. So we're going to underline that. And we've already chosen x. So let's keep the same x. Decreased by, that's another operation. And if you're not familiar with these words, again, we had them in pre-algebra. We're just kind of going through the same thing, a little bit more advanced here. Decreased by, subtraction, minus, all those things mean subtraction concept. So subtracted from, decreased by, less than. All these things are subtraction concepts. So decreased by means subtraction. Now, if there's anything that I can stress to you, it's this right here. All operations are written in order unless they have one of two words, the word from or the word than. If you see those two words, it reverses the order. This is why a lot of people get word problems wrong. They're written like this. Because if you read from or than, it's not the number minus, it's minus the number. From or than reverses the order of operations. If you don't see those, so like our example, a number divided by 5 equals the number decreased by 24. We don't have the word from. We don't have the word then. That's great, because what that means is that you can literally just write out everything in your word problem, and it's in order. So we underline these things to go, okay, a number. What's the number? Well, x. Divided by 5, you can put divided by 5, but I would prefer if you put the fraction. So written in order. A number divided by 5, literally in order. Equals, equals. The number. Decreased by 24. Minus 24. That's a whole lot easier to solve than that is. Yeah, you know what? It is a linear equation. Yes, it does have a fraction in it. The first thing you would be doing, hopefully, since you watched the last video, change everything into a fraction. Find the LCD. Do you know what it is right now? Can you see that the LCD is 5? We wouldn't include these because those are our numerators. You'd have denominators of 1, 1, and 5. Your LCD is 5. How many places would you multiply the LCD? Well, how many terms do you have? Multiply 5 here, here, and here. These don't cancel, simplify, whatever. This one does. You'd end with x, you'd end with 5x, and you'd end with 5, whatever 24 is. And then you'd have something that's very, very easy to solve. Try that on your own. If you're struggling with the fraction idea, watch the last video. I explained how you get rid of fractions in equations. That's not the purpose of this video. This video is how to get from here to here. Your job now is solving that thing. So this is the changing of a verbal model into equations. Let's try the next one. See if you can underline, start thinking about as I'm talking through it, some of these words that mean math. If you've written this down, start underlining them right now. So let's read it carefully 2 times. 5 times a number, some things are popping in my head right now, is 24 more than twice the number. Okay, let's read it 5 times. I know what that means. A number, I'm getting that is. What's is mean? Is one of those words that means equals. That's the key word here. There's never going to be more than one word in an equation that means equals, because there can only be one equals in a math equation, in a linear equation. So 5 times a number is, okay, that's big. 24 more than, oh, right now in my head I'm seeing one of those words that reverses order. So I'm keeping that in my head. This is what reading carefully means. You're getting this stuff in your head. Not doing anything with it yet, but you're getting in your head. I know what times means. I know what a number means. I know what is means. More than, okay, that than, that's going to reverse some stuff. Twice the number, that's a multiplication concept of 2 times. So we're getting this stuff in our head, and now it's time to start underlining. So let's go from left to right. 5 times. I know that times means multiplication. Probably not an x, because that looks a lot like a variable. Let's put a dot, because we know that means multiplication. 5 times a number. Okay, I know what a number is. A number is going to be a variable. Is, that's the big one. Is means equals. So I know that all this stuff is going on the left of my equal sign, and whatever this is, it's going to go on the right-hand side of my equal sign. That's it. 24 more, now more than. More than is the concept of addition, but it has one of those words in it that flips the script, that flips the order. That's a big deal because this is where students get really confused. So when you get the word from or than in your word problem, instead of writing just plus, I don't want you to write just plus. I want you to write plus 24. Because when I say flips the order, what I mean is this more than this. It's not 24 plus, it's plus 24, and it's going to come after the next thing that this references. So 24 more than says, okay, take the next thing, whatever it is, and add 24 to it. So for instance, if I say, I have $5 more than you, you have to take your money first and then add my $5 to it, don't you? You got to know what I'm referring to. The words from or than are reference words that refer to the next thing. So 24 more than whatever comes next says you're going to add 24 after whatever comes next. Now if you're thinking, who cares? Freaking addition. It's commutative. Yeah, I get it. But wait a second. If it's subtraction, it's not commutative. If it's division, it's not commutative. So we have to know that the words from or than, and we're going to practice it now, that those words from or than are reversing words. They're reference words to the next thing, so that we don't make mistakes on stuff that isn't commutative. That's why we practice it now. So 24 more than, it's plus, yes, but it's plus 24, not 24 plus. This is the biggest mistake that happens on these type of problems. Okay, after that, twice. When you have twice something, like twice 50 would be 100. Twice 1,000 would be 2,000. It's a multiplication concept by the number 2. So when we underline twice, we have 2 times the number that we've already picked. So let's look at one more time. We're going to keep some things in our mind like from or than, and then we're going to just go left to right. Every one of these operations is written in order. It's all in order unless you have from or than, and we've already talked about it. So let's write let's write the equals down. Let's write 5 times a number. There's no from, there's no than. 5 times a number. You literally just write this. 5 times y. Done. You're good. The left-hand side of your equation, that expression is done. On the right-hand side, 24 more than goes, all right, yeah, we're going to add. We're going to add 24, but it's referring to the next thing. So I'm going to add 24 to whatever this is. 24 more than what? Well, more than 2y, more than twice the number, more than 2 times y. So we have our 2y, no problem. And then this says, take whatever this is and add 24 to it. Notice how the more than, that word than, puts it at the end of your equation. Puts it at the end of whatever comes next. That's it. That's your linear equation. Looks a whole lot easier, right? I mean, you could combine like terms, no. Distribute, no. Simplify, no. Fractions, no. Get rid of the smaller variable, yes. You get 3y, and then just divide by 3. Answer should be 8. Try it on your own. The last one. So 2 less than twice a number divided by 5 equals 4. Okay, I have some pictures in my head, but I'm going to read it again carefully. See if you can do it on your own as well. If you want to pause the video, now would be a great time to try to read this again. Try to get some operations in your head. Look for some key words here. Look for the word that means equals. Kind of obvious. Not a problem. But also look for some reversing words, some reference words. That's a big deal. So 2 less than twice a number divided by 5 equals 4. So I'm going to start from left to right, read real slow and careful. 2, number 2, got it. Less than, okay, less than. Less than is a subtraction concept, but it has one of the words from or than. So the other way that you see it would be like subtracted from. So 2 less than, 24 more than, or subtracted from, that's the other reference word. So less than. Oops. 2 less than, I know it's subtraction, but it is not. Here's the big deal. It is not 2 minus. This is not in order. This is a reversing thing. So this says 2 less than. So I'm going to put my minus, but I'm going to put minus 2. Because I'm going to take whatever comes next, whatever it is, and I'm going to subtract 2 from it. So subtract 2 from that, or take 2 less than that. It's a reference word to the next thing. Twice we already discussed. A number, we know what that means. Let's pick z here. So I'm going to take 2 less than, yeah, I'm going to be subtracting, but I'm going to be subtracting 2, not 2 and then minus. 2 less than twice a number. Now, oh, the comma. Sometimes these are ambiguous, and you could make a case either way for how this goes. It's why these are kind of rough sometimes. 2 less than twice a number divided by 5, most of the time that comma refers to take this entire thing you just wrote and divide the entire thing you just wrote by 5. It's not, in this case, taking the number divided by 5 and then taking twice that and then subtracting 2 from the whole thing. It's going backwards in that. It's taking this whole thing, dividing this whole thing by 5. So divided by, we know that the division concept, equals, we know the word means equals. So let's look it up one more time before we write anything. This is a big deal. Take your time on these. It's not worth anything to get the wrong answer quickly. Okay, because what's going to happen here is you're going to spend a whole long time. If you go quickly through it and get the wrong equation, you're going to spend a lot of time on the wrong equation. That's worthless. Let's get the right answer slowly. So 2, okay, I know I'm writing 2 less than. Okay, less than means I'm subtracting 2 from whatever comes next. What's coming next? Twice a number. 2 less than twice a number. So we're taking that 2 away from what it's referencing. Divided by 5, it says take whatever you had previously, this whole entire expression before the comma, divided by 5, and the only thing that's after our equal sign is 4. Think about how you would solve it. Does it make sense on where these came from? Does it make sense that's still a linear equation? Does it have a fraction in it? Can you get rid of the fraction? Sure. Your LCD, if you're looking at it, you put the 4 over 1, your LCD is 5. Multiply both sides by 5 and simplify the 5. After that, we'd add 2, we would divide by 2, and we'd be done. Try that on your own. Your first step, if you want your first step, is right here. Your LCD is 5. Multiply both sides by 5. You would have a 4 over 1 here. Do not distribute this. The only reason you multiply by 5 is to get rid of those 5s. 5 divided by 5 is 1. Over here, nothing simplifies, but you end up getting 20. That's a whole lot easier to solve than dealing with a fraction like we had. That's the only way that we can really do that problem effectively. Add the 2, divide by 2, and you'd end up getting 11 out of that. Hopefully this makes sense. It's a first start on dealing with any word problem is from a verbal model. Identify what the operations are, identify what your variable, singular, is, and if you see the words from or than, put that operation backwards from the order that it's written. That will give you a huge heads up on this stuff. The key ones, the really key ones are less than, so like -2, or subtracted from, minus whatever number they gave you. That's it. Next time we're going to start on some more advanced word problems. We're going to slowly trudge our way through these ideas.